Hey there. Today we are going to crack the code on one of the most famous challenges in all of math, the quadratic equation. And don't worry, we're skipping all the dense textbook stuff. In just the next few minutes, we're going to make this whole thing crystal clear. Let's dive right in.
So, have you ever looked at something like this and just thought, what am I even looking at? Is this some kind of secret code? It totally can feel that way, but I promise, by the time we're done here, you are going to be the boss of this equation.
So first up, let's just give this thing a proper introduction. Think of this as its official identity card. What is this thing we're actually dealing with?
Okay, so this is what we call the standard form. The A, B, and C, they're just placeholders for numbers. Any numbers. But there is one absolutely critical rule. A cannot be 0. And think about why, right? If A was 0, that all-important x squared term, poof, it vanishes. And just like that, it's not a quadratic anymore.
All right, so when a teacher or a textbook hands you one of these, what's the actual mission? What are you trying to do? Well, your goal is always the same. Find the roots. But what in the world are roots?
It's actually pretty simple. The roots are just the values of x that solve the puzzle, the numbers you can plug in that make the whole thing equal 0. And here's the really cool part. Every single quadratic equation has 2 roots. Now, those 2 roots can come in a few different flavors. You might get 2 totally different real numbers, or you could get the exact same number twice. And sometimes, you get something called imaginary roots, which is a whole other level of cool math for another day.
Look, every mission needs the right equipment. So let's open up what I like to call our solver's toolbox. Because inside, we've got 3 incredibly powerful tools that can crack pretty much any quadratic equation you'll ever see.
Okay, tool number 1 is factorization. This is your slick, quick draw tool. It's absolutely perfect for when the numbers are nice and simple. The whole idea is basically a little number puzzle. You find 2 magic numbers that let you break the equation into simpler parts. When it works, man, it is by far the fastest way to get your answer. Now, our second tool is called completing the square. I'll be honest, this one's a little more involved. But its real genius is how it forces the equation into this beautifully neat, perfect square package. It's really the behind-the-scenes hero that shows us why our third and final tool works every single time.
And here it is, the big one, Tool C, the quadratic formula. This thing is the universal key. It works on every single quadratic equation. No exceptions, no questions asked. You just figure out your A, B, and C, plug them into the right spots, do the arithmetic, and boom, it spits out your 2 roots. It is your single most reliable friend on this journey.
So, now you've got the tools. You're ready to solve anything. But what if I told you there was the secret weapon? A little trick to predict the kind of answer you're going to get before you even do any of the hard work.
Well, there is, and it's called the discriminant. Honestly, this is such a cool shortcut. It's like having a little crystal ball that gives you a sneak peek into the future of your equation.
All that predictive magic is hiding in this one little expression, b squared minus 4ac. Now, take a close look at that. Does it seem kind of familiar? It absolutely should. It's the exact same piece that's living right under the square root sign in that big quadratic formula we just saw. And that is where it gets all its power.
And this table right here shows you exactly how it works. If that b squared minus 4ac part turns out to be any positive number, you can bet you're going to find 2 different real roots. Graphically, that means your parabola is going to cross the x-axis in 2 places. If it comes out to be exactly 0, you'll get 1 real root that's just repeated. The graph just comes down and kisses the x-axis in 1 spot. And if it's negative, well, you can't take the square root of a negative, right? At least not with real numbers. So you get no real roots, and the graph never even touches the x-axis at all. It's amazing.
All right, that is enough theory. Let's get our hands dirty and actually put these new tools and our new predictive powers to the test. Let's solve one together.
So here's our practice problem. X squared minus 5x plus 6 equals 0. This is a total classic.
We're going to use our fast tool for this one, factorization. So, first step, identify your team. A is 1, B is -5, and C is 6. Now for the puzzle part. We need 2 numbers that multiply to give us our C, which is 6, but add up to our B, which is -5. After a second, you land on them. -2 and -3. Perfect. Once you have those, you can rewrite the whole equation to look like this. And from here, the answer is just staring you in the face. The roots have to be +2 and +3. And just like that, problem solved.
Okay, wait. Before we move on, here is a massive pro tip. This is a super common mistake, so listen up. In the problem we just did, notice that the b value was -5. It is so easy to just ignore that little minus sign and use +5 instead. But that one tiny detail will send your answer way off course, so always double-check your signs.
Okay, so you have the toolbox, and you have the root predictor. You're pretty much a pro. But what if I told you there was one last trick? What if you could solve some of these just by looking at them?
Seriously, you can. Look at our equation one more time. Just focus on the last number, 6, and that middle number, -5. We already found the two numbers that multiply to 6 and add to -5, right? They were -2 and -3. Well, here's the magic trick. Whenever the a value is 1, your roots will just be the opposite of those two numbers. So, the opposite of -2 is +2, and the opposite of -3 is +3. It's not really a formal method, but it's an incredible shortcut that helps you build your intuition and solve simple equations in a flash. And just like that, you've officially cracked the code.